Hello students, welcome back once again to my maths class. In today's lesson, we are going to talk about a new concept, that is the geometric progression. Right, and those who have not watched the previous videos of the progressions, that is the arithmetic progressions, 3 parts, do watch them and proceed to this video. Now we will be starting with the geometric progression, the concept of geometric progression, as well as the exercise involved in it. Before that, I would like to tell you a short story. Okay, now in olden days there was a king, an emperor, who is very fond of different types of games. Now he had a wise minister with him. This wise minister, one fine day, he bought a new game to play with the king. Now the king was very interested to play that game. Now that game was nothing but a game of chess, right? So the game of chess. Now you all know the game of chess, right? How many squares does it have? It has 64 squares, 8 cross 8 squares. Now, so these two, the minister as well as the king, they played the game of chess, and the king found it very pleasant and he wanted to reward the minister. So what he told him to choose any prize, worthy prize. But the minister was very wise. He told the king that he want only a few grains of rice, but he told that he would be giving a condition that in the chessboard in which they were playing, he told the king that he would like 1 grain in the first box and 2 grains in the second box, likewise doubling them 4 grains. See here, 8 grains likewise. Now what he told the king, I simply want grains of rice which would fill all the squares in this game, so that they should follow a sequence that I want first grain in my first box, that is first square, this in the second box 2 grains, and to doubling it 4 grains, doubling it 4 into 2 comes to 8. So 8 grains in the fourth box. Likewise here he would have 16 grains, right? Now 32 grains here. 16 to 32. Here it comes to 64. So he gave that condition. But king was very surprised. He told that, oh, so sanctioned, he told, and he gave him. But if you see the pattern here, the minister was too wise. He was asking for grains, but he kept the condition that each box will be doubling the grains of rice. So if you see that when they reached, now in this process of doubling, when they reached the 17th square, in this process when they reached the 17th square, the grains were doubled in such a fashion that the whole table was filled up with the grains. Now, and likewise, when they reached 26th square, now there are 64 squares, here 8, no, like this, when it reached the 26th square, the whole room where they were sitting were filled up with the grains. Likewise, then when they reached the 40th or the 40, the whole palace was filled with the grains. So that means, what do we infer from this story is that since the minister was too wise, he was asking for few grains which were doubling in each square. Now, if you see in this story, now the minister was telling 1 grain in one box. The second grain, it was doubled. 1 was doubled to 2. Now doubling means multiplying, okay, into 2, 4 grains here, into 2, 8 grains here, 16 grains, here 32, here 64, likewise here if it comes to 128, like this. So the doubling each grains. Now if you see this pattern, it is following some sequence, right? Now as we all know, the AP, that is the arithmetic progressions, which we have studied before classes. In this pattern, there is A plus D, A plus 2D, so on. There is a common difference, that is a constant, for which if you are adding the constant to the previous term, you get the all terms. adding the same constant to the previous term, we will be getting the terms in AP. But here, if you see this pattern, just adding does not work out here. There is some other pattern here. If you see here, if I tell this is 1, now this is going to be, if I multiply something to this first one, so if I suppose, so to get the second one, I have to multiply with 2, so it comes to 2. Now if I multiply with 2, it comes to 4. This is the third one. Now if you multiply the third term with 2, it comes to 8. Now 8 2's 16, 16 2's 32. That means, what am I doing here? Just multiplying with 2. Here the 2 is constant. Constant term I am multiplying. The constant is 2. So if I am multiplying with each preceding term, I am getting the next term. So this is following a pattern such that we can generalize this pattern as, if I tell this as first term A. Okay, now what is that which we are multiplying here is the constant. Let us suppose this constant as some R, right? That constant. So I am multiplying the second term with R into R. That means A into R. Okay, I am supposing it is R. I'll tell you why we are supposed it as R. Okay, now the third one, again for the preceding one I am multiplying R. So it comes to R into R. Now here R into R into R. So one constant I am multiplying for the preceding one. So this is going on. That means if you write here A, this is AR to the power 1. 1 means only 1 R. Here AR to the power 2. 2 R's are there, so raised to the power 2. Now AR to the power 3. AR to the power 4. So this is the general form of GP, that is the geometric progression. Right? Now, here in geometric progression, this is one geometric progression. There is a pattern that the first term is A and it has been multiplied with a constant. I have told this constant as R. Now, why we got R? Because here, if you see in GP, AR, I was telling AR square, AR cube and so on. So this is 1, you can mention it as 1. Now why this is called as R? Because if I divide here, if this is first term, second term, third term, fourth term. How do I get the R? I am just multiplying with the preceding one. Now I want R here. If I want R, if you divide the A2 by A1. See here, the term which is succeeding, that term divided by the previous term, you get R. See, A2 is what? AR1 by A1 is just A. If you cancel A, you get R. Again, if you see any two terms, see this one, A3 divided by A3 divided by A2. Okay, A3 is here A2 square by A2 is AR1. So if you cancel A and this 2 R's here, so 1 R I cancel, so I get only R. So this R is, why am I dividing here? This R is called as a ratio. That's why I have written R. I haven't taken some constant K. Why I have written R? Because it is a ratio. Isn't it? Dividing means that's nothing but a ratio. Now, this ratio throughout the series is common because I'm multiplying with 2 here, the constant term. And if you divide the succeeding one with the preceding term, also you get the same value. That means throughout the series, this ratio is common. So, I call it this as common ratio. So, common ratio is R. Now, let us variate here. Now, we have in our AP the common difference, right? What's the common difference? D. Okay. That D which you add to the preceding term, you get the next term. You are going on adding. Here the ratio, the constant term, you are multiplying with the preceding term, you will be getting the next term. That is the difference between GP and AP. GP is the geometric progression, in short called as GP. So, the general form of GP is A, AR square, AR cube, so on. Now here the common ratio, how do we get the common ratio? By dividing the successive term to the preceding one, like this, AR by A, that is A2 by A1 or A3 by A2, any terms. Throughout the series, the ratio is common. So, this is R. And the general form of GP is AR square, AR cube. Now, let's find out the nth term of GP. Now, here, I am telling these are the terms in GP. That is first term, second term, third term, fourth term. Clearly see this pattern. Now, in A2, the second term, we got R1. And if you see A3 here, A3, that is the third term, we get R2, R to the power of 2. That means there is one less R here. Here, if it is fourth one, there is one less, that is R3, 4 and 3. So, likewise, if I want to write nth term, that means this power here. Nth term, it comes to AR, 1 less, that means n minus 1. So, this is the nth term of GP or the general term. We can call it as general term or nth term. AN is equal to AR n minus 1. So, one term is getting less because we have started with A. Same as we have done in the AP. AP is one term less D, the common difference. For A2, A plus D, A3, A plus 2D. Likewise, in GP, we have AR raised to the power of 3 is 4. That means 1 less here. So, the nth term is AR raised to the power of n minus 1. So, I hope you have understood the complete geometric progression concept. Now, with this concept, we will be doing the exercise problems. Exercise 6.4, the first problem. In which of the following situations does the list of numbers involved in the form of a GP? Now, there are 3 conditions given, the 3 problems, and which are the situations of GP is when asked. Now I'll be doing for you the second one. I'll read out the second one. Number of bricks needed to make each step if the staircase has total 30 steps. The bottom step needs 100 bricks and each successive step needs 2 bricks less than the previous step. Now the situation is given here. We have to see whether it is forming a GP or not. Okay, let's see the second problem. Solution. Now here given there is a staircase to be built up. Now the total staircase is having, now how many steps? 30 steps. So 30 steps. Total steps of staircase. 30 steps we are having, right? Now in the bottom one, 100 steps were laid. That means first step, bottom step has how many bricks? Has 100 bricks. Now it is constructed with 100 bricks. The bottom step, that means the down one. Then 2 bricks less. The next one has the 2 bricks less. That means 98 bricks. Next step has 98 bricks. The other one, the next step has how many bricks? 2 bricks less means 96 bricks. Likewise. So let us write the pattern. The first step is having 100 bricks, right? The next step is having 98 bricks. Now the third step is having from bottom 96. So 2 less means 94. So on. So likewise there are 30 steps. So n is 30 here. And here if you see it is GP or AP, we have to find out. See, first term is 100. And how do you get the second one? How am I getting? If I minus 2, I am getting here. Minus 2, minus 2. 2 bricks were less, isn't it? Minus 2. So, the constant here is D, that is minus 2. right? Or else if you also subtract, see, the A2 minus A1, you get minus 2. So we got A and D, we are not getting ratio. If you want to find the ratio, 98 by 100 is not equal to 96 by 98. Clearly, that means it is following a pattern, that is A and D, that therefore it is not in GP. It is not in GP, but it is AP, right? So the situation is in AP, not the GP. Now quickly copy down. Let's do the next one. The second problem, write 3 terms of the GP when the first term is A, the common ratio R are given below. Now here there are 4 problems. I'll be doing the 2 problems, that is the second and the third we will do. Now the second one is A given as root 5 and R given here 1 by 5, right? So ask, find out, write the 3 terms of GP when A and R are this. Now what is the general form of GP? Here the general form of GP is A, AR 1, AR square, AR cube, so on, where the nth term is 1 less, so n minus 1. This is the general form of GP. Now we have to write only the 3 terms. Now wherein the first term is given and the common ratio is given. So let's substitute. Now if you want the first term, A is equal to root 5, already given. Now the second one, this is A1. A1 is A. A2, the second term is AR. So A is root 5 into R value is 1 by 5. Now in 5 we have 2 root 5. So if you cancel this, you get here 1 by root 5. See here 5 is, you can write 5 as under root 5 of 5. 1 root 5 if you cancel with up, you get 1 root 5. Okay. A3. Now the third term is AR2. Now it is 1 less, isn't it? Now A is root 5 into R value is 1 by 5, but it is square. So root 5 into 1 square is 1, 5 square is 25, or else just write 5 into 5, because we'll cancel it with root 5. Now if you cancel this root 5, again only root 5 is left over here. So 5 root 5 is the third term. Now asked to write only the 3 terms, right? So therefore the 3 terms are, what are the 3 terms here? Root 5, 1 by root 5 and 1 by 5 root 5. That's it. Now pause the video quickly, write it down. We'll be doing the next one. The third problem in the same bit, A value given as 81, the common ratio is minus 1 by 3. We have to find the other 3 terms. We will write the general form of GP. AR1, AR square, so on. Nth term is AR and minus 1. So the first term, that is A1 equal to A equal to 81. Now the second term A2, that is AR. So A value 81 into R value is minus 1 by 3. Okay. Now you cancel 3 ones, 3 twice 27. So there is also minus. So minus 27 is the second term. Now the third term is AR square. So 81 into minus 1 by 3 is R whole square. Now this comes to 81 into minus 1 whole square is plus 1, 3 square is 9. Right, 9 ones, 9 nines. So the third term is this. Therefore, the 3 terms are here. First one is 81 minus 27, 9. Okay, this is the series. Now quickly copy down. Pause it and copy down. We'll see the next one. Now the third problem, which of the following are in GP If they are in GP, write 3 more terms. Now there are few problems in this. I have noted down the second and the 8th problems. Right. Now the second problem is 1 by 3 minus 1 by 6, 1 by 12. We have to find whether they are in GP or not. Then after finding, if it is in GP, then we have to find the next 3 more terms. Now we'll check whether this is in GP or not. How do we check this as GP or not? Just by seeing the ratio, the common ratio throughout the series must be constant, right? So if it is constant or not, we will be checking it. Now the first term is A, that is 1 by 3, right? Now here, if I suppose this as A1, A2, A3, these are the terms. Now the common ratio is R. What is R? It is the ratio of the succeeding to the preceding one, A2 by A1, or else we can also say A3 by A2. See here, why am I finding 2? Because we have to see whether this series is in geometric progression or not. That's why throughout the ratio is constant or not, we will be checking it. So these 2 terms dividing and these 2 terms dividing. So R value, what is A2 here? 1 by 3 minus 1 by 6, that is A2 by 1 by 3. Now here A3 is 1 by 12 divided by A2 is minus 1 by 6. See here. Now by, this comes to the upper part, that it becomes reciprocal. See here, if I tell you 1 by 6, this fraction, if it comes up, it becomes a reciprocal, 3 by 1. Here, this side also 1 by 12. If you bring this to the upper side, it becomes a reciprocal. Right. Now here 3 1s, 3 2s are. So this is minus 1 by 2. Here 6 1s, 6 2s are 12. So minus in fractions, remember if the minus is in denominator or the numerator, it comes to the whole fraction. Now don't keep the minus in the denominator itself. It comes to the whole fraction, bring it above. So minus 1 by 2. So we can clearly see that the common ratio throughout the series is same. Therefore this series is in GP. It is in geometric progression. Now ask the next condition, that if it is in GP, we have to find the next 3 more terms. Now next 3 more terms means given in the series till 3. So next 3 means A4 you have to find. Now what is A4? A4, A5, A6. Okay. A4 is A R 1 less. That means n minus 1. So 4 1 less, it is Q. Now A value, will substitute A value is 1 by 3. And the R value, how much we got? Minus 1 by 2 raised to the power of 3. Okay. Now if I do this, it comes to 1 by 3 into minus 1 whole cube. It comes to minus 1 again. 2 whole cube is 8. So if you multiply, minus 1 by 8 3s are 24. So this is the 4th term. We need to find other 2 terms, right? Here, let me find A5. So this is AR4, 1 less. So 1 by 3 into R value is minus 1 by 2 raised to the power of 4. So this comes to 1 by 3. Minus 1 whole square becomes plus 1, and 2 raised to the power of 4 comes to 16, isn't it? Now this is 1 by 16 3s are 48. Now the next term A6, that is AR5. A is 1 by 3, R is minus 1 by 2 raised to the power of 5. So 1 by 3 into minus 1 raised to the power of 5. Minus 1 multiplied 5 times. So it comes to minus 1 only. 2 raised to the power of 5 comes to 32. Now if you see minus 1, 32 3s are, that comes to 96. So these 3 are the next 3 terms. So 1 minus 1 by 24. Here next one is 1 by 48 and 1 by 96. So minus in alternate terms. These 3 are the next 3 terms of this GP. Now we will see the next one, that is the 8th one. Here given A value First we have to check whether the series is in GP or not. Now A value is the first one. Now R, that is the common difference, is when I suppose this as A1, A2 and A3, common ratio, common ratio is A2 by A1, that is equal to A3 by A2. So we have to check whether the ratio is common throughout the series. So R equal to, what is the A2 value here? -2 by A1 is 1 by root 2. Here A3 value is 4 root 2 by A2 value is -2. Right. Now see here, this fraction, if it comes up, it becomes a reciprocal. So -2 root 2 by 1 simply. 4. Now here there is no fraction here. We can just multiply here. Divide. 2 ones, 2 twos. So this minus, you can take it up. -2 root 2. Here also -2 root 2. So the ratio is same. We got the ratio same throughout the series. Therefore, it is in GP. It is GP clearly. Now, if it is in GP, we have to find the next three terms. So, the A4th term is AR cube. Substitute A and R values. A value is 1 by root 2 into R value. How much we got R value? -2 root 2. So, whole cube. Right. See here, A value is 1 by root 2. R value is -2 root 2 whole cube. Now we will be cubing this 1 by root 2 into -2 whole cube is -8. Right. And root 2 whole cube. Root 2 into root 2 will become only 2 and again into root 2. That comes to 2 root 2. So root 2 whole cube is 2 root 2. That is root 2 whole cube. We are taking 1, it is 4. 4 we are taking out, it comes to 2. So root 2 cancel. Here there is 2 left over. So this comes to -16. 8 into 2. Only I have cancelled root 2 here. 2 is also left over. So -16 is the A4th term. Now A5th term, AR raised to the power of 4, 1 by root 2 into -2 root 2 raised to the power of 4. Right. Now here it comes to 1 by root 2 into -2 raised to the power of 4 comes to 16. Right. Now root 2 4 times. So that is nothing but root 2 4 times, that is root 16. So 4 comes out. So if I want to cancel here, so if I write this as 1 by root 2, 16. So you can write it as 2 into 2. 4 I can write it as 2 into 2. In 2 I can cancel this. Here you can also write it as root 2 into root 2. 1 2 I have resolved into root 2. In 1 root 2 will be get cancelled. So 16 2s are 32 root 2. Okay. So here 4 I have written it as 2 into 2. Again 2 I have written it as root 2 into root 2 just to cancel the root 2 which is in the bottom. Likewise find out A6, AR 5. So A is 1 by root 2 into -2 root 2 whole to the power of 5 here. Now that comes to 1 by root 2. Here -2 raised to the power of 5 is -32. Right. And root 2 raised to the power of 5 is, that comes to 4 root 2. Isn't it? 4. Here we got just 4. Here one more root 2 is there. 4 root 2. So this root 2 and root 2 gets cancelled. Now here simply -32 into 4. How much it is? 4 2 is 8, 4 3 is 12. So that comes to -128 simply. So these are the three terms. Next three terms, the fourth term A4 is 16 minus, here this is 32 root 2 and the A6th term is -128. So we have checked it for the GP and we have found out the other two terms. There are few more problems in the same bit. You practice the problems. Quickly pause the video and note it down. Last problem in this exercise. Find the fourth problem. Find x so that x comma x plus 2, x plus 6 are consecutive terms of a geometric progression. So they are given that they are the consecutive terms and we have to find out the x. Okay. Now here the problem. The series is x, x plus 2 and x plus 6. These are the consecutive terms. They mentioned it as that is in GP. They are in GP. We have to find x value. Right. Now, if they are in GP here, we can clearly see that if this is the first term, this is the second term, this is the third term. So, if they are in GP, they have to satisfy the condition of the common ratio. Now, the common first term is A1 equal to A equal to X, right? Now, to satisfy the common ratio, we will see here R is equal to, it is the ratio of A2 by A1 and A3 by A2. Because it is in GP, it should satisfy the condition of common ratio. Now, what is A2 here? A2 is x plus 2. A2 x plus 2 by A1 is x. Now, A3 is x plus 6 by A2 is again x plus 2. See here, I have noted only the terms A2 by A1. They have to be equal because it is told that they are in GP. So, now from this condition, if you cross multiply, now here it comes to x plus 2 whole square. So, this is x into x plus 6, right? Now, if you expand this, this is in the form of a plus b whole square identity. So, expand it a square plus b square, that is 4 plus 2ab, 4x. So, I have expanded in the form of a plus b whole square. Now, simply to the other side, it is just multiplying x square plus 6x. Now, if you see x square, both the sides here, x square is there. So, you can cancel x square, or else if you bring x square to the other side, it becomes minus x square. You can cancel the x square. Now, here if you see, it is, now if you send this x to the other side, so here 4, now 6x minus 4x, right? Now, this comes to 2x equal to 4. Now, x value is equal to 4 by 2 divided. This is multiplied, so it comes to the other side, becomes divided. 2 once, 2 twice. So, therefore, clearly x value is 2. Right. Now, like this, we can find out the value of x. Now, children, this is the last sum and I have left over few problems for you to practice. Hope you would practice them today itself, and thank you.